Welcome back. In this demo, we will launch AKS cluster with a single node with Azure Policy add-on enabled, and will apply some policies through Policy Blade from the portal, and then finally we will validate the results. So let's start. So here we are in Azure. Let's go ahead and launch the Cloud Shell. Let's first create the resource group. Resource group, my resource group in the location East US has been created. Now let's go ahead and create the cluster. In this command, I mentioned the name of the cluster as my AKS cluster. The resource group, my resource group, enable add-on, that is Azure-policy, --node -count is 1. So that will be the number of worker node within my cluster. This command will take time. Let's come back once the cluster is ready. It took around 4 to 5 minutes for me to get the cluster launched. I can see all the information there. Now I will download the kube config file in order to connect to the cluster. Let's run the command AKS get credentials. My kube config file has been downloaded. Now I should be able to connect to the cluster and run kubectl get nodes command. It's working. I can see there is a worker node running as part of this cluster. Now let's run kubectl get ports command. No resource found in default namespace, and that is obvious. I don't have anything running in my default namespace. Now let's validate the installation of Azure Policy add-on onto this cluster. I will see the corresponding ports inside the namespace kube-system. Let's run kubectl get ports -n kube-system. So here I can see there are two ports running, Azure-policy and Azure-policy-webhook. So these ports are basically part of your add-on. And now let's run kubectl get ns command. There is a namespace also added, and the namespace name is gatekeeper-system. Let's see how many ports are running inside this namespace. Kubectl get ports -n gatekeeper-system. Hit enter. I can see there are 3 ports running, gatekeeper-audit, and these are 2 replica of a deployment gatekeeper-controller. That proves that the installation of Azure-policy add-on was successful. Now let's run kubectl get constraint template to see if we have any existing constraint template onto this cluster. I don't have any. And now let's run kubectl get constraint to see if there is any constraint exist onto this cluster. I don't have any. Sometimes it takes time. By default, I should be able to see some constraint template and constraint. So let's wait for a while. Let's run the command once again, kubectl get constraint template. I can see there are some constraint template created. Now let's run kubectl get constraint. I can see number of constraint also created. There are 2 most important points here. The first one is you cannot edit, patch or update these constraint and constraint template using kubectl command. You have to edit those from the Azure policy. The second one is all the constraints are just dry run constraint. Those will not prevent anything to happen. Let's rerun kubectl get constraint template command once again. Let's copy the constraint template AKS Azure container no privilege and expand the definition of this. Get constraint template, paste the name here -o YAML. So this is the definition file of this constraint template. Let's understand this. This object is of type constraint template. We have some annotation here. The name of the constraint template is AKS Azure container no privilege. Under spec section, we have kind set as AKS Azure container no privilege. Under validation, some validations are there. And then under target, we have very most important section about Rego. This section is very important. All the policies are written in Rego language. We have package, we have import. This is the library which it is importing. Under violation, we have the message what you want to print on the screen when something is not allowed. This is the violation it is checking. So if you are creating any code with a container of privileged, then it will fail and it will give you this message: privileged container is not allowed, and will give you the security context, the name of the container, and the security context name. Now let's expand the definition file of constraint itself. Let me just go through the definition of constraint template once again. So this is the kind here, right? And this is the CRD which it is creating, and that is the CRD for my constraint. Let me just copy this and run kubectl get name of the CRD. Hit enter. You will see this is my constraint created. Now let's expand the definition of this constraint. I'll just run the command kubectl get the constraint kind and the constraint name -o YAML. Hit enter. This is my constraint definition. Let's go through it at a high level. We have kind, metadata, some annotation set, then we have name of the constraint. Under spec section, we have a parameter enforcement action set to dry run. That's very important. As I said earlier also, the constraints are created, but those are all dry run. Those will not prevent anything to be created or launched. So I will show it to you. I will try to launch a pod with a privileged container and it will be launched. The policy will not be checked. It will be bypassed. Under match, we have some namespaces which we are excluding from this policy. Under kind, we have API group, and the kind is basically pod. So it is only checking this policy for pod. Under parameter, we have nothing set here, and that's it. This is my constraint definition. Now let's do one thing. First, I will try to modify the constraint by opening the YAML file into edit mode. I'll do what? I'll just run the same command with edit. Now let's try to change this enforcement action to deny. It's failing. The message is it could not be passed. Admission webhook denied the request. This cluster is governed by Azure policy. Policies must be created through the Azure. For more information, please visit this link. So you cannot edit any constraint or constraint template using kubectl command. So that has to be done from Azure policy from the portal. Now let's do one thing. I will try to create a pod with privileged container in it. Let's write the definition file of the pod first. Let's call it as pod.yaml, and this is the definition file of my pod. Very simple, nothing fancy. So here the kind is pod, metadata, the name of the pod is nginx-privilege-1 container. This is the name of the container. Image is a simple nginx image I'm using. Security context, I'm using privilege 2. In this case, we are going to create a pod nginx-privilege-1 which has a container running in privilege mode. Let's save this and try to apply this definition file. Let's run kubectl get pods command. My pod is running successfully. The constraint policy is bypassed here. That's the reason the pod is created, and we knew the reason why it is getting bypassed. There was a parameter enforcement action is set to dry run within my constraint definition file, and the parameter cannot be changed using kubectl command. In order to change this, we need to create a definition from the Azure policy and apply it from there. Let's do that. So I will open a new tab and will go to Azure policy. Let's click on assignment. Currently I have an assignment already there in place. That is for something else. Let's click on definitions and create a definition. Under category, I will unselect everything. We'll search for Kubernetes. Select it. Let's type pod security baseline here. I'm gonna select this definition. I'm gonna assign this definition. Let's choose the scope here. I'll just choose the scope as demos. We'll choose the resource group as my resource group. Click on select. Let's click on parameters. I will uncheck this, and within effect I can use deny. That's what I want. I don't want port to be created if it has a privileged container in it. These are the namespaces which you want to exclude from the policy. Namespace inclusion, you can add a namespace which you want to include explicitly here. Remediation, I will not change anything. Non-compliance message, I will not change anything. Let's click on review plus create and create the definition. So assignment has been created. Let's close this. Click on the definition. I can see the definition has been created. Let's click on the assignment also. The assignment has also been done. So it is already assigned to your Kubernetes resource group, my resource group. It will take around 30 minutes to apply this policy onto the Kubernetes cluster. Let's come back once the policy is applied. Let's clear the screen and run the command kubectl get K8s Azure container no privilege. Hit enter. Now I can see there are two constraints exist now. One is the one which has dry mode enabled, and second one is the one which is created from Azure policy. Now let's see the definition file of these two constraints. kubectl get, this is going to be the type space the constraint name -o YAML. So this is the one which was just created through the Azure policy. Enforcement action is set to deny. And the second one is the one which was created by default when we enabled the Azure policy add-on onto this cluster. And in that constraint, enforcement action is set to dry run. Let's validate that once again. Let's copy the constraint name from this output and run this command against the new constraint this time. The enforcement action is set to dry run. My pod is still running. Let's check the status of the pod. I will run kubectl delete -f pod.yaml file. Pod has been deleted. Let's run kubectl get pods command to verify. Yes, it has been deleted. Now let's try creating the pod once again. Yeah, this time it is getting failed. Let's read the message. Privileged container is not allowed. Error when creating pod.yaml admission hook. So now we have admission hook which is preventing this pod to be created, and that is because of constraint what we have created through Azure policy. Right, so this was one of the example where I used a constraint to prevent Kubernetes admission controller to create any pod where the container is privileged container. Similarly, I can have other constraint also applied to the Kubernetes cluster. Right, so that's it for this demo. I hope you liked it. Thank you.